The audience for this video include hardware and software engineers developing ESP32 microcontroller-based projects. This ESP32 project shows how to solder a breadboard wired project to a PCB board. The next two screens show the various soldering tools that I use. This shows a pencil-style digital soldering iron that I normally set at around 700 degrees. The second is a desoldering iron, which is handy for removing solder to remove a previously soldered component. I highly recommend investing in two soldering iron stands, one for your soldering iron and the second one for your desoldering iron. Here are some of the other tools I use on my projects. I do want to point out that I use 22 gauge wire on the breadboard, and I use 22 gauge wire on the soldered boards. In this video, I'm demonstrating how I strip a 20 gauge wire, and I'm going to fit it into the PCB board, like pulling off the, you might want to keep the colors on the thing. I prefer just taking the color of the sleeve off of the wire. To me, it just makes a little cleaner looking design when you're finished. It's personal preference. I'm going to fit this. In this particular example, I'm just trying to jumper from one side of the prototype board to the other side of the prototype board. So I'm just making a little bend in the wire there, and then I'm going to sketch it or etch it with a little knife, just a little mark, so that I know where to bend the wire. So I'm removing it there, and you can slightly see where the edge is, and I'm going to bend it at 90 degrees here, and then it should fit into the two holes that I had aligned it with. I'll get it in there in a second. And once I push it in with my thumbs, and then I like turning the board over, and with a pair of needle nose pliers, I'll grab a hold of it and tug it, make it nice and snug, pull it up tight, and then bend the wires over so that they'll stay in place while I make the permanent connection. So lay that down here. Now I'm going to show the soldering iron. I'm not actually hooked up, plugged in, and heated, so it's kind of like a fake solder I'm doing, but you get the idea. I'm using this plastic tool to kind of just even out raise it just a bit. I don't want any shorts. So far I haven't had any problems with getting shorts using these wires. They stand up a good 30 seconds of an inch above the layer of the board, so I haven't had any shorting problems. And then I'm just taking my solder here, and of course again this is kind of fake right here because the iron's not hot. Just showing what I would do. I heat up around the hole and where the solder is, and usually within like under 2 seconds of heat, boom, it fills in. You can put the solder flux on that if you want. Sometimes I'll do that I have a solder flux pin where I can pinpoint a hole and just kind of get a little bit of flux around it. Makes the solder flow a little bit easier. Generally not needed, but occasionally something is stubborn. So then when I'm done soldering, I fold up the two metal clips, and then I'll just take these little handy snips. They can get really close to the face of the board there. They don't, and they make a nice clean cutoff. That's basically how I do it. It's a process. I really do like converting my breadboard wires that have been pushed into this technique onto a final board. This image shows several female PCB headers. I'm showing a 4-pin, 6-pin, a 7-pin, and I think a 16-pin. I use these. I like to solder these in wherever I'm going to plug a component in, so that if the component fails, I can just pull the component out and plug in a replacement without having to unsolder. Unsolder using the desoldering iron works, but it's a painful process and not real clean. So in fact, sometimes when desoldering, you end up scratching the board and breaking certain contacts on the PCB board itself, and and that causes problems trying to trace down why something's not working. But anyways, I'll show how I install one of these female PCB headers and solder it into place. In this video, I'll show how I solder the PCB header. Position the header, try and get it so it's like a 90-degree angle to the board, and then I'm just taking a piece of masking tape to secure it in place, hold the pins firmly into the board, and just so it doesn't move. And then I can flip the whole circuit board over, and I'll have, in this case, I think it was a 16-pin. Then I would make 16 different solder points there. So in this case, again, my soldering iron isn't hot. I'm just sort of demonstrating where, how I would apply a little bit of heat and solder each of the pins. So anyways, real simple to add these, and saves you a lot of time by putting these in. I built up a supply of them myself, and I have like 3-pin, 4-pin, 6-pin, 7-pin, 8-pin, 16-pin PCB headers. They fit a variety of different size components. This video shows a completed soldered PCB board. Flipping it over, showing you that in this particular case, I had to solder some wires to the bottom that lead to a second board. It was simple to do too, just solder to the bottom. And this is the final image of this PCB soldering project. It shows the various components populated in their female PCB headers.